The purpose of the Redox experiment post-lab sheet is to help you learn to use your Redox table to determine if a reaction occurs or not. If a reaction occurs, it's said to be spontaneous, and using our Redox table, we'll get a positive voltage for that reaction. A reaction that does not occur will get a negative voltage, and it's said to be non-spontaneous. So you're always going to be given a few reactants, and your job is to determine if they will react together. To do that, you're first going to list the substances that could be oxidized or reduced. If the substance given to you is a solid, liquid, or a gas, that substance will go directly into the list. So copper is a solid, we're just going to put copper in the list. Zinc nitrate is AQ. Anything that is aqueous needs to be split into ions. So this will split into zinc 2+ and NO3-. Those two substances will go into our list. Whenever we have an aqueous substance, we know that substance is also dissolved in water. So it is possible for water to be oxidized or reduced. Anytime you have an aqueous substance, water will be in your list. For this homework assignment, the list will always be full. So if I give you 4 blanks, there are 4 substances that could be oxidized or reduced. 6 blanks, 6 substances. After we make our list, we need to determine the substances that would be easiest to oxidize and easiest to reduce. We'll start with easiest to oxidize. We're going to look at the left-hand side of our oxidation reduction table, and what we're looking for is one of the substances in our list on the reactant side of one of these half reactions. So we're just going to scan along, and the first thing we might notice here is zinc. But if we look, we need zinc 2+ to be on the reactant side of this reaction. And on the table, zinc 2+ is on the product side. So that is not the reaction we're looking for. We need to keep looking. So we keep scanning along, and we'll notice copper here. So copper is in our list, and it is listed on the reactant side of this oxidation half reaction. And that makes sense because copper is a metal. A characteristic of metals is that they lose electrons. Oxidation means lose electrons. So when you're looking for the substance that's oxidized, most often it's going to be a metal. So copper is the substance that's oxidized, and now we'll write the half reaction and the voltage from the redox table on the oxidation half reaction line. So now we repeat this process using the right side of the redox table, looking for the substance that's easiest to reduce. So if we scan along, we'll see we got NO3-, and in our list we have NO3-, but we got to be careful because in this half reaction you also need H+, and we do not have H+ in our list. So that is the incorrect half reaction. So keep scanning. We'll see there's another reaction with NO3- and H+. NO3- we have, but H+ we do not. So that is not the reaction we are looking for. So if we keep looking, keep scanning along, oh, we got copper again, Cu+. But in our list we don't have Cu+, we only have Cu. Remember, the substance in our list must be on the reactant side of these half reactions. Cu+ is not in our list. So that is not right. Keep scanning. Well, there's Cu2+. Same thing. We don't have Cu2+. So that's not the correct half reaction. Keep scanning. We'll get there eventually. Keep scanning. Uh-oh, here we go. Zinc 2+ is in our list. It's the only reactant we need. So that is the substance that's going to be reduced. Substances that are going to be reduced usually include nonmetals or cations. Cations have lost electrons, so they are free to gain electrons again. Nonmetals, remember, by definition, want to gain electrons. The substances that are going to be reduced are usually nonmetals or cations. So let's write Zn2+ as our substance easiest to reduce and write that half reaction down with the voltage. And now we just need to add the half reactions together to get the net ionic reaction. This one's pretty easy because we have 2 electrons on the product side of our oxidation reaction and the reactant side of our reduction half reaction. So they are going to cancel. If the number of electrons doesn't cancel, then you'll have to multiply one of the half reactions by a whole number multiple in order to get the electrons to cancel. But in this case, they cancel, so then we just add them together. We have copper plus zinc ions goes to copper 2 plus zinc. And we're also just simply going to add the voltages together. So when you add negative 0.34 and negative 0.76, we get negative 1.10. So now we can answer if this reaction is going to occur. If you have a negative voltage, the reaction will not occur. This reaction is non-spontaneous. Let's try one more. This one should be a little bit easier because potassium and water are your only reactants, and one of them is going to be oxidized, the other is going to be reduced. Since they are a solid and a liquid, we don't have any AQs. We don't need to worry about splitting anything up into ions. Our list is simply K and H2O. So let's find one of these substances on the oxidation side of our redox table. Now, if you think about it, remember, metals, the characteristic of metals is that they want to lose electrons. If I had to make a bet, I would bet potassium is going to be oxidized. So let's take a look. And we don't have to look very long because potassium is third from the top. It really wants to be oxidized. It really wants to lose electrons. So potassium is the substance easiest to oxidize. Here's the half reaction and the voltage. Let's look for water now on the reduction side. It has to be just water. So there's plenty of reactions that have water in them, but we're looking for the one that just has water as a reactant. And we scan along far enough down and we get to this reaction here. So we can see water is going to be reduced. And there's the half reaction with the voltage. So now you can see an example here of when trying to add these half reactions together, we have to have the electrons cancel out. So we have to multiply the oxidation half reaction by 2 in order to balance the electrons. One very important thing here, when you multiply a half reaction by a multiple, you do not multiply the voltage. The voltage is the same. Do not multiply the voltage by 2 in this case. Our electrons will cancel, and now we can just copy down our net ionic equation is 2K plus 2 H2Os goes to 2K plus H2 plus 2OH minus. Adding our voltage together, we'll see we get 2.09. It is a positive voltage, which means the reaction is spontaneous. So now it's your turn to practice using your redox table to determine if reactions occur. I'm going to flip through a few here and just get you your list. So on the top of page 2, system number 3, we have aluminum solid and AuCl4AQ. This is an ion. It's a polyatomic ion, so you don't need to split that up. So the three substances are aluminum, AuCl4 minus, and since it's aqueous solution, we also have water. So those are your substances that could be oxidized or reduced for system 3. If you look at system 6, we have a bunch of aqueous substances. So we got to split all those into ions, H plus, SO4, 2 minus. Okay, SO4 is 2 minus, so that means Fe here must be Fe 2 plus. Potassium is K plus, MnO4 is MnO4 minus. All of these are AQ, so that means you also have water. So your list is composed of those 6 substances. Your job now is to determine which one is easiest to oxidize and reduce to see if a reaction occurs. System 7, in the middle of page 3, you have H2O2 liquid and KNO3 aqueous. Well, the liquid stays the same, don't break it into ions, and then we have K plus and NO3 minus, and since KNO3 is AQ, you also have water. So those are the substances in the list for system 7. Those are the reactions that cause the most difficulty for students, so I figured it would be helpful if I helped you at least determine the substances that could be oxidized or reduced.